recording. Okay, so we should be recording, and I wanted to welcome everyone to the session tonight. Before I forget, and I will put this in the weekly announcement that goes out for next week, the poll that ended yesterday, 12 of you participated. Thank you very much for those of you who did. And 75% said that Monday was the best night for them. 25% said Thursday was the best night for them. So we'll be meeting from now on Monday nights at 7 p.m. in Zoom. And so I will make sure to put that in next week's announcement so everyone knows when to come in. That's the night I usually tend to meet. The reason I wasn't available at the beginning of the week, my daughter graduated from Columbia Teachers College last Tuesday. And so we were in New York City to celebrate that with her. So that's why I said I would have to go ahead and meet on Thursday this week so we could all get together. But my thought is, okay, then just make sure, Michael, that you listen to the recording. If you listen to the recording and send me your completed guided notes, I can give you credit for that assignment. The assignment itself is not graded attending the meet session. Of course, those students who do the best in the course attend every meet session because I've deliberately chosen things to go over that you're going to see in Connect Math, that you're going to see come test time. And I used some of those problems and explained the concepts that I know are very important. So the students that do best attend the meet sessions regularly. If you can't, just make sure that you listen to the recording. You'll get the guided notes just like you did this week, so you can complete them. The sessions usually run an hour and a half to 2 hours. So you may not be able to stay for the whole session, but even if you could come to the beginning, Andrea, and then leave and pick up the recording where you left off, that would work as well. Now, to get attendance for this course, it's pretty cut and dry. There are 5 assignments every week in this course. Just about every week. We've got the interactive lectures, which you need to listen to. We've got the meet session that you can attend. There's a practice homework on Connect Math. You have to get, I believe, at least an 80% in that before you can open the homework quiz, which is your 4th assignment. And then there's an application assignment that you can work with your partner on if you choose. You each need to submit your own assignment, but you're welcome to work with your partner on that assignment, and then each submit your own assignment. And I've gotten some partner assignments from people who read the text or who read the material and who participated. So thank you very much, those of you who took care of it. If you have to leave, it depends on how much is left, Andrea. The college rules say that you have to be there for 3/4 of the class to get attendance credit for a class. That's if it's a face-to-face class. So I would think probably every week would be okay. There'll be maybe 1 week where we go 2 hours. That's chapter 7. That's a bit of a long one. Everything else should be around an hour and a half. A couple of the last lessons are only about an hour because they're shorter. So yeah, so as long as you're here, then that should be good. Okay, Tiara, to clarify, you don't have to work with a partner at the beginning. No, I will be assigning you a partner about midway. Application assignments, they shouldn't be identical, is what we were told by the lead faculty member. You can work together, but you still need to do your own work. So you need to answer each one in your own words or in similar. Obviously, what we're trying to not set up is for one person to do a lot of the work and the other person just to copy. You need to be working together on this. So, there's not really a definitive answer for that, but we're trying to keep copying at a minimum, obviously. So let me see, I said we'd be meeting on Monday. Oh, I was talking about the attendance policy. So I named the 5 assignments, and we'll go over them at the end of our notes here as well. If you do at least 3 of them, you get attendance credit. They have to be completed, so you can't just get a part of an assignment done and have it count. It has to be complete. So for example, for your practice homework to count, you have to have at least an 80% in the practice homework. Otherwise, it's not done. So that's kind of the one that I'm talking about there. And as long as you have at least three or four or five, we're good to go. If you have a difficult week and you only submit 2 assignments or only submit 1 assignment, then you're going to get marked in that as absent. On your 4th absent, I think it's, wait, I'm sorry, on your 3rd absence, you get a Z in the class, which is a type of failing grade at Franklin. So I think a lot of you know about that already. One thing I need to mention, SLC, the Student Learning Commons, they have a very good review session. You can attend review sessions for every class that we teach. You can also attend review sessions for the midterm and the final. You have to sign up for those sessions, I believe. So go to the Student Learning Commons and just make sure that you avail yourself of all the tutoring and help that Franklin provides. Something that's a little different, if any of you are repeating this course, there will not be the three tests that we used to have. There are only 2 tests now. There's a midterm that's going to be done on Connect Math through Proctor. Is it Proctor? What is it? The testing center that will proctor you on the computer. You can use that for the midterm only. So you need to sign up for that. ProctorU. That's right, ProctorU. You'll need to sign up for that using the Test Proctor icon that's on the course page. After the midterm, you're going to have to sign up for Test Proctor again, because the final exam, which is cumulative, is going to be given as a paper and pencil. So you have 1 computerized test, 1 paper and pencil test. So you're going to have to sign up for a Test Proctor twice. I just wanted to make sure that you knew about that. So you'll find them on the course page. The first Test Proctor object is, I believe, in week 1 or week 2, and then the second one is in week 7. So just don't forget about that. I think that takes care of all of the kind of particulars. I sent you the welcome announcement, and that explains things in more detail there. But any more questions from you guys before we move on to our notes? All right, I'm not seeing anyone accessing the chat box, so I'll just assume that everyone's good. And I will go ahead. If anyone is joining late, obviously you'll need to let me know you're here. I've got this set up so that I can't see participants. So Melinda, Erica, to be clear, okay, sorry, some things are coming by fast. So Melinda, let me see what you have. To be clear, first pair assignment this week, we do not have to do with our partner. Yeah, yes, that's up to you. Yeah, whether you work with your partner or not this first week. Can there be more than one bias in the survey? Yes, there can be more than one bias. Will there be notes that you send to us each? Yes, I'll send you notes each week, just like I did this week. And anything else? All right, okay, well, we'll get started, and I'll keep an eye on that chat box as we go along. Feel free to use your mics if I'm missing that. It's a little bit difficult to keep up with everyone. Do we submit the notes? Oh, they're just for you, Catherine. The notes are just for you, unless you're listening to the video recording and you weren't attending the meet session. Then the way to show me that you listened for the to the meet session is to send me the completed guided notes, and then I give you credit for that. There are some study guides for the test. They won't be available until later. I do have a study guide for the final. The midterm is new this semester, so I'm not sure how they're going to handle that. I think the only study guide, there is going to be a review on Connect Math that you can do that's worth some points. So yes, there will be some review materials for the tests. Both of them, actually. All right, so let's take a look at what we're going to be doing. We're going to be covering Chapter 1 this week. So we have a survey here that was taken, that was given. And the headline for it says, the majority say research has improved health. So here's one of the questions that they asked on the survey. Whoops, let me just get this where you can see it. I am so sorry. This is going to take me a little bit of time. So do you mainly agree or disagree that your health has been improved thanks to research over the course of your lifetime? And so we see that 33% strongly agree that it has been helped. We see that 12%, the yellow slice, they're not sure. So you can see we've got our legend over here on the right, and we've got what we call a pie chart that tells us how these, what proportion of the people that were participating in the survey selected these answers. And this was done by Zogby International Analytics, and I've given you the source there. This was done in 2016. So we see here, oh gosh, I'm sorry, that the National Online Survey was conducted by Zogby Analytics on behalf of Research America in January 2016 among 1,001 adults aged 18 and over. This survey has a theoretical sampling error of plus or minus 3.2 percentage points. So we're going to use this example just to kind of review and go over some of the terminology that we have here. So we had a sample of 1,001 adults. Who can pick out the definition of the sample here from A, B, C, or D? Just go ahead and type your answer into the chat box. So what are you thinking here? Everyone's saying D. Actually, that's the population. The population is all individuals of interest. A sample isn't going to be all of them. We didn't ask every single American what they thought. We only surveyed 1,001 adults. So yeah, A is the correct answer. Well, nope, not A. So we know it's not D. We know it's not A. Okay, there we go. Melinda said D, and she's right. A sample is some of the individuals of interest. So notice that sample begins with an S, as does some. Some begins with an S. The population, the key word for population is always all. So population is all, sample is some, and usually we have a definition of what some means. Here we would say that N is equal to 1,001. N is our sample size, and you will see that throughout this semester, that symbol. So that is the size of the sample. So moving on to variable. We asked a variable here, do you believe that your health has been improved due to some research over your lifetime? And so a variable is something that information that we get from individuals that can vary from person to person. So some of us are going to think, yes, my health has improved, because of the research. Others are going to say, no, not so much. So yes, a variable is C, a characteristic of interest that varies from individual to individual. What about parameter? So let me see, we've got B, C, and D taken care of. So parameter and statistic are going to have to be matched with A and E. So if you look at A and E, you see that they're both numbers that describe a characteristic. One is for a population, one is for a sample. So again, the alphabet's going to help us here. Parameter goes with population. They both begin with P. So a parameter would describe some characteristic for a population. So what does that leave for statistic? E, yeah, and again, we can use the alphabet as our help. Statistic begins with an S, as does sample. Sample begins with an S as well. So here we have some very key terms that you're going to need to become very familiar with. We're going to be working with these terms all semester. So some of the things to really remember: a sample is some, the population is all. A statistic describes the sample, they both begin with S. A parameter describes a population. They both begin with P. So if we look up at our pie chart here, here's a good follow-up question. Are these numbers, the 12%, the 33%, the 4%, the 11%, the 41%, are they statistics or parameters? And Melinda's saying that they're a statistic, and she's right. Why are they a statistic? Where do these numbers come from? They came from the sample. Perfect. They only came from the 1,001 people who participated in the survey. And I don't know about you, but I was not one of them. So probably didn't include any of us here in the class tonight. So we're going to look at variables in depth. This first lesson is basically all about definitions and terms. So we're not going to be doing a lot of calculation this first week. And in fact, the second week, we're not going to be doing a lot of calculations either. We'll kind of start calculating in earnest when we get to chapter 3 and week 3 and talk about descriptive statistics. But tonight, we're introducing a lot of terms that are going to be what we're using all semester. So we'll be practicing these and having examples of them. So as we said, variables are, it's information that we get from individuals, and that information can vary from individual to individual. There are two types of variables. There's qualitative variables and there's quantitative variables. Now, qualitative variables, they categorize. Quantitative variables either count or measure something. So when we look at qualitative variables, let's practice with a few of these variables right here. So here we're going to be taking a look at some variables that are qualitative or quantitative. So what about the color of a car? Is that going to be qualitative or quantitative? Yeah, it's going to be qualitative. Good. What about the age of the car? Quantitative or qualitative? Quantitative, very good. What about the mileage in miles per gallon of the car? Good, quantitative. Awesome. What about the model of the car? Yeah, that's going to be qualitative. A model is going to be, I don't know, I have an ILX. I'm not real familiar with a lot of the models anymore, but there's the TL, there's, I think, the Escape, that type of thing. What about the size of a car? Subcompact, compact, sedan, SUV, measuring the size of the car that way. That's also going to be qualitative. Awesome. And the purchase price of the car. Yeah, it's going to be quantitative because it's something that we would count. It's going to be an amount of money. So as you look at the variables that are qualitative, what are their values? Are the values of qualitative variables words or numbers? Yeah, they're words. And that's one way to tell them apart. So their values are usually words. What about the quantitative variables? Are their values words or numbers? Numbers, right. So sometimes if you're identifying the type of variable, if you can think of some possible values that that variable could take on, that might help you. If they're numbers that count something or measure something, it's going to be quantitative. If they're words that describe some category, then they're going to be qualitative. Now, there are two types of qualitative data. There's nominal qualitative data, and that names only. Then there is ordinal data. That is, those are names that can be put into an agreed upon order of some kind. So let's practice those definitions. So which of the following variables, they're all qualitative variables, by the way, Which of the following variables are ordinal and which are nominal? So what about the size of the car? Is that going to be ordinal or nominal? Okay, I see some answers, ordinal and nominal. That's actually going to be ordinal because we know that the subcompact is the smallest car. The compact car is small, but it's not as small as the subcompact. We've got the sedan, which is a little bigger, and then the SUV is usually the biggest. So since there is an order by size, that's an example of ordinal data. What about the model of the car? Well, that's going to be nominal. There's no order to the models of the cars. What about the color of the car? That's also going to be nominal. And finally, the length of the loan for the car. And this is going to be 36 months, 48 months, 60 months, etc. That's going to be ordinal. The 60-month loan is longer than the 36-month loan. You know, the 48-month loan is in the middle. So there is an order that can be established there. So we also have some types of quantitative variables. So backing up here a little bit, there are two types of quantitative variables. When we count to get our number, we call that discrete data. Now your textbook might say it's a finite number of values that are distinct. It just comes from counting. When we count, we have discrete data. When we measure, we have continuous data. Now, when we measure, the variable can take on a value that is anywhere in an interval. So it doesn't have to be discrete, finite number of values. So looking at our quantitative data, let's see if we can identify which is continuous and which is discrete. So what about the age of the car? Is that going to be continuous or discrete? Yeah, the way we talk about age, for example, my car is 6 years old now. It's a 2013 model. So I would say I've got my car is 6 years, is 6 years old. We go to the nearest year is what we do. We don't really measure. We just count how many years from the present time to when our car rolled off the assembly line. So we can say that that would be discrete. What about the mileage of the car in miles per gallon? And yeah, most of you are saying continuous. I would take continuous or discrete. Continuous is probably the better answer because we actually measure miles. We might have 32.3 miles per gallon or 32.432 miles per gallon. It's a measurement. If some of you are thinking that, okay, I'm just going to count the number of miles in a gallon, then you would say discrete. So it really comes down to think about how you would get these values. Do you count to get them or do you measure something to get them? And that's going to guide you guide you to whether it's discrete or continuous. What about the purchase price of a car? What do you think about that? Yeah, that's going to be discrete because we always count money. So sometimes people get a little confused, and a car could cost $16,428.32. There can be decimal points in discrete data, and that's always the case with money because we always count money. We just count to the nearest penny. However, when we write money down, we write it down in dollars. So a penny is 100th of a dollar. That's why we have to introduce the decimal point. So whenever we've got money, automatically discrete. What about the number of doors on the car? Two-door, 3 door, if you've got the back hatch, 4-door. It's going to be continuous or discrete. And that's also going to be discrete, right, because we count them. All right, so that pretty much takes care of our data variables. Any questions about how to type data variables, qualitative, quantitative, and then to indicate nominal, ordinal, interval, or discrete or continuous? So everyone's looking good on that? Awesome. All right, so let's look at the next page. I don't know why I've got a blank page in here. So we're going to take a look at sampling methods next. Now, it's really important that samples are selected in such a way that they represent the population from which they are drawn. So the following methods are acceptable ways to select a representative sample, with one exception. And I misspelled exception there. Sorry about that. There should be no S in that. I'll just try to scribble that out. And we'll pick that up as we go along. So if you've listened to the video lectures already, you probably know which one I'm talking about. So a lot of these things were covered there. So, sorry, just trying to get this out of the way here. It's not going to let me. Okay, we'll do it this way. So a simple random sample of size n is a sample chosen by a method in which each collection of n population items is equally likely to comprise the sample. So if you've got your notes in front of you, which I hope you do, because I can't show you all of the notes in one page on the share screen, you're going to see that I have some scenarios, A, B, C, D, E, and F. One of those scenarios is an example of a simple random sample. Can anyone pick out which sample is the simple random sample? And you just give me the letter number for it, or the letter for it. Good, Catherine, you're right. It's option B. B is our example of a simple random sample. So let's kind of scoot down to B and see what makes it so. So if you look at B, I have a physical education professor who wants to study the physical fitness levels of 20,000 students enrolled at her university. She obtains a list of all 20,000 students and numbers the records from 1 to 20,000, and then uses a computer random number generator to generate 100 random integers between 1 and 20,000. Then she invites the 100 students corresponding to those numbers to participate in the study. So a simple random sample, in order to ensure that every sample has the same chances of being selected, it's kind of like drawing names out of a hat. So, you know, the education professor could have every student at the college put their name on a slip of paper, throw the slips of paper in a hat. It would have to be a pretty big one because there are 20,000 names. And she could just reach in, shuffle them around, and randomly select 100 of those slips of paper. And that's really what is involved in a simple random sample. It's that idea. Now, of course, with computers, we have, you know, more high-tech ways. We don't have to all write our name on a piece of paper and put it in a hat. We can use the computer to generate some random numbers and mimic the same thing that we're doing with that. So anytime you see random number generator involved in the selection of the sample, that's going to be a simple random sample, SRS for short. So let's take a look at the next definition. A convenience sample is a sample that is not drawn by a well-defined method, random method. A convenience sample can provide biased information, which is faulty information about the population. If it is reasonable to believe that no important systematic difference exists, then it is acceptable to treat the sample of convenience as if it were a simple random sample. So I've given an example. I'm sorry, I'm trying to move this out of the way so I can write it down. Given an example of a convenience sample. Can you pick it out from the scenarios below? So a convenience sample is going to be selecting from individuals that are convenient to the person. So actually E is going to be a little more complicated. That is a well-defined method. And F, okay, that's our sample that will never be a random sample by any means or stretch. D, Catherine's got it. D is the correct scenario for that. So let's take a look at that scenario and see what makes it a convenient sample. So if I come down a little bit to D, in order to learn about the amount of student loans that are being assumed by today's college students, I ask you, the 12 of you or the 10 of you who are attending tonight, I ask you guys, to anonymously submit the amount of student loans incurred to date. That would be an example of a convenient sample. You're convenient to me, you're right here. I'm just going to go ahead and use what's convenient to me. Now, I could probably argue that it could be considered a random sample. Math 215 has to be taken by all Franklin University students. It's one of their basic requirements, one of your gen eds. That's what we used to call them when I was in college. And so anyone attending Franklin or getting a degree from Franklin, I should say, is going to be taking Math 215 somewhere along the way. So it would be a good representation if I were looking at the student loans incurred by Franklin University students. Now, if I were looking at the amount of student loans incurred by all college students, then the convenience sample would not be representative, because Franklin's a private institution and costs a little more than some of the public institutions. And so it wouldn't be representative of all college students. It would be representative of private college students, but not of the public college institutions. So, depending on what population I'm trying to represent, that convenience sample could be a representative sample, in which case we can consider it a random sample, or it may be a bias sample, a sample that's going to give us some faulty information. So the students in this class, those who are close by, is what makes it a convenient sample. F is also done with a convenient method, but it's got a few more problems with it, so it has its own special name. We're going to get to that in a minute. So the next sample that we're going to talk about is a stratified sample. So in a stratified sample, the population is divided up into groups. We call these groups strata. Then a simple random sample is drawn from each of the groups, each stratum. Stratified sampling is useful when the strata differ from one another. For example, when we want to do gender studies, male versus female. But individuals within a stratum tend to be alike. So think one of the classic ones is thinking of splitting it up by gender. Not always, but that's a good example of one. So which of the, and I'm seeing some A's, good, you guys are good. Now, I'm going to come back and tell you a little bit, I'm going to point out something as we look at A here. A company has 80 full-time and 200 part-time. So here's our strata, full-time and part-time employees. We're hired by this company to conduct a study of employee satisfaction with salary and benefits. We randomly select 80 full-time employees and 20 part-time employees to be in our sample. So notice that we select some individuals from each strata, from each group. So you kind of think of the word some with stratified. The next sampling technique can be a little confusing, with the stratified sample, because in cluster sampling, items are drawn from the population in clusters or groups. So again, we're going to be grouping our population, just like we do in stratified sampling. But we're going to treat these groups differently. Cluster sampling is useful when the population is too large and spread out for simple random sampling to be feasible. So what we do when we select a group from the population or a cluster, we use everyone in that group to be in our sample. And we select several clusters, but not all of them. In stratified sampling, we get some from every single group, from every single strata, so or stratum. So which of these examples is going to be a cluster sample? Yeah, it would have to be E. That's right. And remember, here we're going to use all of the individuals in the selected clusters. So if we look at E, to estimate the amount of student debt, I randomly select 15 colleges in Ohio, and I obtain the amount of debt for all students at each college. So all students, I select some groups, some colleges, and I use all of the individuals in those groups. In the stratified, I selected some from every strata. And in cluster, I use all of the individuals from some of the groups. So that's kind of the difference there in that. Sorry for those noises, not sure what's going on, but we'll just try to ignore them. So in systematic sampling, items are ordered and every key item is chosen to be included in the sample. Systematic sampling is sometimes used to sample products as they come off an assembly line in order to check that they meet quality standards. So which of our remaining scenarios is going to represent that? Yeah, it's pretty obvious it has to be C. So we use systematic sampling and quality control. So maybe we're making automobiles. We talked about getting data from automobiles earlier. So maybe we work at Honda or someplace like that up in Marysville. So automobiles are coming off the assembly line, and we need to select a representative sample for detailed check of the steering system to make sure that we're manufacturing safe cars that meet the standards. So the starting point will be the third car that comes off the assembly line in this shift, and then every fifth car after that will be sampled. And so they'll be pulled aside, and we'll check, do a detailed check of the steering system. So we often use that in quality control in a manufacturing setting. Finally, we have the voluntary response samples. These are often used by media to engage the audience. What's our only remaining scenario that's left here? It's pretty easy, yeah. This has to be scenario F. And so the voluntary response samples, they're problematic. They are not random, and by random we mean representative. Oh, I know what those are. When people leave and come in, we get little sounds here. Sorry about that. Not random or representative samples. So this is the one that is not a good sampling technique. We want to watch out for it. So very typical. The news anchor on the evening news invites listeners to participate in a phone-in survey expressing their opinion of President Trump's recent handling of the Russian connection. This is a little bit old, probably, his recent handling of, I don't know, maybe the trade talks with China or whatever it is that's in the news today. But that would be, yeah, radio station uses them. A lot of times online, anytime you participate in an online survey, those are going to be voluntary. And we're going to find out in our last section tonight that there are some biases with the voluntary samples. Voluntary samples often I would say always give us biased information, because only those people who are passionate about the issue of the question or the survey tend to participate. Those of us who don't really care, which is probably the majority of the population, we're not going to bother to take our time to participate in that survey, or especially to incur any costs in order to participate in that survey. So, those, we have to watch out for those surveys, and yet they're often frequently used. They just don't tell us anything. That's what we have to remember. So we're going to move on to the types of statistical studies that we're going to be talking about in this course. So we have basically three types of statistical studies that we're going to be looking at. We have, oops, sorry, I touched something. Let me see here. How do I get this back? Oh, I'm sorry. Let's see here. Okay, let's do this. And let me see if I can just resize this a little bit. There we go. Okay, we're back again. Sorry about that. I've got a touch screen, and if I brush anything, I get in trouble. I should know better. So we've got types of statistical studies. So we have sample surveys, which you've already talked about. We opened our discussion tonight with a sample survey on the condition of our health based on the recent research that has been done. We also have observational studies and randomized experiments. So our sample studies or our surveys, the purpose of a sample study or survey is to estimate a certain population parameter. So if we go back to our first page, that was a sample study. We're going to look at another one here in a minute. We were trying to estimate the population parameter for some of these opinions. So again, the question was, do you mainly agree or disagree that your health has been improved thanks to research over the course of your lifetime? And so we could say, well, 33% of the individuals who participated in this survey strongly agree that this is the case. One new message. Okay, let me see. Oh, you can no longer see the, okay, got it. Give me a minute to figure out what's going on here. Okay, all right, I'm not gonna do that. Let me get this, oh gosh, okay. All right, let me see if I can move this over. All right, I can see this. Where's my share? All right, let me find it and start sharing it again. Okay, now then, just give me a second. I am so sorry to pull up the chat. This is my only way to make sure. Okay, can you see it now? Okay, good, thank you. I'll get better as the semester goes on. I hope this doesn't discourage you from attending, but you knew the first couple of weeks are going to be rough because this is a new piece of software for me. All right, so let me get back to where we were. So we were talking, I was talking about, that's right. We did this survey. We asked 1,001 individuals, and 33% of them strongly agreed that their level of health had been improved because of the research that's gone on during their lifetime. So we said earlier that was a statistic, but the purpose of a sample survey is to estimate the population parameter. So when we look at the title of this study, we're going to see the majority, and we're talking about the majority of the population, say research has improved their health. So if we add the somewhat strongly agree to the somewhat agree, of course, we're going to get 33 plus another 41. That's going to be 74%. That's our majority. 74% of all Americans feel that their health has been improved because of the research that has taken place in their lifetimes. So that's the whole point of a sample survey. It's to survey a sample to get an estimate for the population parameter. Now, we're going to have to estimate population parameters because we can never get the entire population. We can never get information from the entire population. By the time we surveyed every single adult who's alive in this moment, the statistics tell us that a certain number of them have passed on and a certain number of them have reached their 18th birthday and are considered an adult for legal purposes. So this population of adults in any country is constantly changing. It's dynamic. So we can, this isn't a PowerPoint, so you need to take your notes as we go along, Bobakar, so that you're able to record whatever you want. I already made it available to you. I sent it out to you at the beginning of the week. So it's not a PowerPoint that I can share. It's just a document that I can share. All right, so hopefully you've got the idea of a sample survey. We're going to talk about another one in a minute. We also have two other types of, let's see if I can get this down here a little faster, of studies, an observational study and a randomized experiment. Now, both observational studies and randomized experiments, the purpose of those studies is to compare two population parameters. So in a sample study, we're estimating individual population parameters. We're not really doing any comparing. But in an observational study or randomized experiment, we're going to be comparing two populations. So let's take a look at this first study. This was a study that was done a while ago. It was just an interesting study to me. Americans seek soulmate spouse. So we've got some single Americans in their 20s want to marry someone who shares their innermost thoughts and feelings, rather than someone rich or of the same religion, a survey said today. Today's young Americans are on a quest to find their soulmate, compared with past generations that sought spouse with similar religious and social backgrounds, said a new survey from Rutgers University National Marriage Project. Seeking a compatible mate who shares similar values is not new, But what is new and surprising is that the soulmate ideal has become the most desired meritable partner characteristic for this age group, surpassing religion, economics, and even the ability to be a good mother or father, said David Popenoe, co-director of the National Marriage Project. Among Americans in their 20s who have never been married, 94% said they wanted a soulmate spouse first and foremost, said the survey, which was called Who Wants to Marry a Soulmate? They were very confident of success. Of those surveyed, 88% agreed that there was a special someone, a soulmate, waiting for you out there, somewhere out there. And 87% thought they would find that person when they are ready to get married. It goes on to give us some more statistics. For 80% of the women polled, a husband who could articulate his deepest feelings was a better catch than one who earned a good living. Only 42% of single Americans in their 20s thought it was important for their spouses to have the same religious beliefs, the survey showed. And so now we've got the kind of important part. The survey is part of the world's wider The State of Our Unions report on marriage trends in the United States. It was based on telephone interviews with 1,003 single and married men and women aged 20 to 29 from January through March of this year. And actually this year was in the, let's see, it was before 2010, I believe. So it's a little bit dated. It's just kind of an interesting one to talk about. So we have a study that was done. Can anyone tell me what type of study this is? What are we trying to do here? Are we going to compare some groups, or are we trying to estimate some population parameters? We're really describing one group in detail. We're not comparing groups. So this would be an example of a sample survey. It even tells us right here. So this is going to be, because we're trying to estimate some population parameters. So name some of the population parameters estimated in this study. So what were some of the population parameters that were estimated in this study? Let me get back to it here. You can just give me their values. What are some of the numbers in this study? That's actually not one of the parameters. That's the size of the sample, Melinda, 1,003. But yeah, 42%. Here's going to be one of the parameters that was measured, the 42%. Thought it was important for their spouses to have the same religious belief. 87%. The age of the people would not be a parameter. That's just going to be, the parameters are going to be in the study itself. So 87% thought that they would find a person that they were ready when they were ready. Here's another one, 88%, 94%. All of these percentages, they are what we found. These percentages are sample, what we call sample proportions, because they are the proportion of the 1,003 married and single men and women who took part in the survey, and they're used to estimate population proportions. So as a conclusion of this report, we might say 94% of all 20-somethings want a soulmate spouse. So we're taking what we got from the sample from the 1,003 and we're attributing it to the entire population. So those are the notions that are starting to be or are being estimated. All right, so study 2. To determine the effectiveness of a new pain reliever, a randomly chosen group of pain sufferers is assigned to take the new drug, and another randomly chosen group is assigned to take a placebo. So, any ideas on what this might be? Notice we've got two groups, and we're going to compare some things between the two groups. The group taking the new drug, the other group who's taking the placebo, who's going to be our control group. Any idea on which of the samples or the statistical studies remaining this might be? The randomized experiment or the observational study? Yeah, there is a control group here, that's right. It's actually going to be the randomized experiment. So we're going to talk a little bit about how we can tell the difference between a randomized experiment and an observational study. In a randomized experiment, the treatments are assigned by the researcher who's conducting the study. We're going to see in a minute that in an observational study, the participants choose their treatments. The treatments aren't assigned, the participants choose. So if you want to determine whether you've got a randomized experiment or an observational study, the best question to ask is who's assigning the treatments. If the researcher's assigning the treatments, it's an experiment. If the participants are choosing the treatments, then it's going to be an observational study. So we have some parts to the randomized experiment that we're going to talk about. The experimental units are the name that we give to the subjects. So what were the experimental units in this study? What are the experimental units? What are the subjects of this study? Or who are the participants of this study? Pain sufferers, right. Yeah. We had a group of pain sufferers who were assigned. So they were assigned to do something, take a new drug. Another randomly chosen group was assigned to take a placebo. So because they were assigned the treatments, this is an example of a randomized experiment, and our experimental units are pain sufferers. What are the treatments? What was assigned to these groups? Yeah, the pain reliever and the placebo. Now the outcome is the response. It's it's going to be a variable, but it's a variable that's responding to the treatments, to the new drug and to the placebo. So what do you think might be responding to the drug and the placebo? It's not clearly spelled out here, so you kind of have to read into the scenario. Sorry. So what are these people suffering from? What is going to change? What's going to change for these people? Yeah, the amount of pain. Yeah, the amount of pain is going to change for these people. Okay. All right. We keep gaining and losing some people. We may have some trouble with the internet connection. All right, so a family practitioner wants to determine whether exercising can decrease resting pulse rate. She measures the pulse of all patients for 1 week and interviews them about their exercise habit. One individual said she exercised an hour a day. She divides the individuals into two categories: those whose typical level of exercise is low and those whose level of exercise is high. The resting pulse rate for the low exercise group was 78 beats per minute. The average pulse rate for all adults is 60 to 100 beats per minute. So what type of study is this? Are we comparing two groups, or are we estimating some population parameters? That'll give you a start. And then if we're comparing two groups, you need to decide whether it's observational study or randomized experiment. Good, Erica. This is an observational study. So again, you need to know why, because you're going to have to pick out in some of your Connect Math homework, you're going to be given a scenario and you're going to have to pick out whether it's a randomized experiment or an observational study. So notice that the treatments are the amount of exercise that they do. All she does is she interviews them about their exercise habits. So she doesn't say that, doesn't randomly select some of her patients and say, okay, you need to do a high level of exercise for a month, and then we're going to look at your pulse over that month, and randomly assign another group of her patients, or randomly select another group of her patients and tell them, okay, you have to exercise a low amount. You've got to, a low level of exercise. No, the person gets to choose. She just asks them, do you exercise a lot? Do you exercise a little? And so the person just reports what they're currently doing. They're choosing their level of exercise. So because they're choosing the treatment, it's going to be an observational study. You don't see the word assigned anywhere in this description of the study. Nothing is being assigned here. But yet we are looking at the pulse rate for low levels of exercise compared to high levels of exercise, because the practitioner wants to determine whether exercise can decrease the resting pulse rate. So, of course, we've got some other terminology we're going to practice here. We have a sample of individuals. So what was the sample that this practitioner used for this study? So it's right here. She measures the pulse rate of all patients for 1 week. So her sample are all patients with appointments during a specified week, or something like that. So not all of her patients had an appointment that week. So what's the population? Yeah, I see all of the practitioner's patients. So sometimes we use the word all when we're describing a sample, but it's not going to be all of the population. It's going to be all of the individuals in some category. What variable or variables, there are actually two of them, what variables did she collect from these individuals? Let's see. Yeah, you can name one of them. We'll write it down and then we can talk about the other one. So what's a variable that she collected? Yeah, the pulse. So she took the pulse rates. So what type of variable is this, quantitative or qualitative? And she also did exercise. I'm going to do that in a different color. So we actually have two variables we can talk. So going back to pulse rate, what type, qualitative or quantitative? Yeah, it's going to be a quantitative variable. And so now we need to decide, is it discrete or continuous? Do you count the pulse rate or do you measure the pulse rate? Anyone who's taken your own pulse rate by putting your thumb on your wrist, outside of your wrist, you count it. Yeah, so this is going to be discrete. Good. So for the other variable, exercise, is that going to be quantitative or qualitative? Yeah, it's qualitative because they either had a low level of exercise or a high level of exercise. So is it nominal or ordinal? Think of low level of exercise compared to high level of exercise. It's going to be ordinal. Yep. All right, so give me a statistic from this study. And you can just give me the value of it. That's actually going to be a parameter because of the word all here. The average pulse rate for all adults is 60 to 100 beats per minute. So that's going to be our parameter. And 78%, because it was the resting pulse rate for the low exercise group only, that comes from a sample. So 78% is, or 78 beats per minute, sorry, is our statistic, and 60 to 100 beats per minute is our parameter. So again, remember, parameters begin with a P, so they go with populations, which begin with a P. And populations are all individuals. So parameters describe all of the population or come from all of the population. Statistics, on the other hand, go with samples. They both begin with S, and samples, so it just comes from some of the people in the population. All right, and the sampling method here. So she just measured the pulse rates of all the patients who had a doctor's appointment this week. What kind of sampling technique did she use? We've got simple random sample, stratified, systematic, cluster, convenience, voluntary response. Convenience, yep. This is an example of a convenience sample. She just chose a week and just took what was convenient. Everybody who had an appointment that week. All right, so the last thing we're going to do is talk about bias tonight. And there's not a whole lot to do here. I just kind of tried to capture some of the essence. So we talked about voluntary response samples being bias samples, and this is why. One of the first sources of bias we're going to talk about is the voluntary response bias. So a voluntary sample is one in which people are invited to log on to a website, send a text message, or call a phone number in order to express their opinion on an issue. In many cases, the opinions of the people who choose to participate in these surveys do not reflect the population as a whole. In particular, people with strong opinions are more likely to participate. In general, voluntary response surveys are biased. So we have self-interest bias as well. Many advertisements contain data that claim to show that the product being advertised is superior to its competitors. Of course, the advertiser will not report any data that tends to show that their product is inferior. So self-bias is when the person reporting the information has an interest that they're trying to support, perhaps a hidden agenda. Social acceptability bias, people are reluctant to admit to behavior that may reflect negatively on them, which affects many surveys. So there's a survey that I used to do with one of my classes. It was a survey about giving to charities or volunteering time at charities. And that's a good example of social acceptability bias, because if you survey someone and said, did you contribute to any charities last year? It's pretty, difficult for some of us to say, no, I didn't commit to a single, um, contribute to a single charity. I kept it all for myself. There's a tendency to do what's socially acceptable and say, yeah, I, contributed, thinking, okay, I'm going to contribute soon, so I might as well say I did. So that's kind of an example of social acceptability bias. Leading question bias. If you've got some untrained pollsters, you could have a lot of leading question bias. Sometimes questions are worded in a way that suggests a particular response. So if I'm wanting to find out the opinions of people for developing a new weapon, say, I could say, are you in favor of developing a new weapon that could save the lives of hundreds of innocent people? That's kind of leading to a yes answer. Saving lives of innocent people is a good thing. However, I could be talking about that very same weapon, and I could say it this way, or ask it this way. Are you in favor of developing a weapon that could kill millions of innocent people? Because, a weapon is going to kill people, and some of them are going to be innocent. And that, phrasing the question that way kind of leads to a no response. Killing innocent people, that's not good. That's not a good thing to do by most of our values. So, leading question bias can affect the outcome. Non-response bias. In any study, a certain proportion of people who are asked to participate just refuse to do so. If a study has a high proportion of people who refuse to participate, this can lead to non-response bias. In other words, we're not getting a fair representation of the population. We're getting, some bad information. That's what bias is. And finally, there's some sampling bias. Sampling bias occurs when some members of the population are more likely to be included in the sample than others. This was a very famous case that happened at the turn of the last century. It was in the 1930s. The Literary Digest reported that Alf Landon was going to win the presidency by a landslide. And actually, Franklin Delano Roosevelt won the, presidential election by a landslide. So what did the Literary Digest do that was wrong? They had some sampling bias. Back in 1936, they used the phone book and they used automobile registrations to get their samples. So they mailed postcards to people who had a phone because they could get their addresses from, the phone companies, and they also used car registrations to get addresses to mail people postcards. Well, back in the 1930s, we were just coming out of the Depression. Only the rich people had telephones and cars. They were relatively new inventions back then. So not realizing it, the Literary Digest had some really strong sampling bias. They were sampling the rich, not the entire population. And back in those days, the majority of the people were very, very poor. So they horribly, misjudged that and actually went out of publication not long after that election. So that's an example of sampling bias. So that takes care of all of the information that we need to cover tonight. As far as the biases go that we just read through, you'll be given a scenario and asked to identify what type of bias is being described. So I tried to give you some stories similar to what you'll be reading in Connect Math, as examples to kind of help you with that. So remember again that you must complete at least 3 of the 5 following assignments to receive attendance credit for this course. Attend the meet session, and the Zoom does record your attendance and how long you've been here. So I'll get an accurate attendance record from that and know whether or not I can count you for attending the whole meet session or not. Complete the Connect Math practice homework assignment, get at least an 80%. Complete the Connect Math quiz. You only have one chance to take that, so what you get is what you get on that. Complete the interactive lecture assignment if you haven't done so already, and complete the application assignment. You may work with a partner on that if you like. Do submit your assignments as instructed on Blue Quill. You don't need to worry about the Connect Math. I will go in and I will get those grades from the Connect Math gradebook and bring those over. But the interactive lecture assignment you'll submit on in Blue Quill, along with the application assignment in Blue Quill as well. So the quizzes, it's hard to tell because individual students take different amounts of time. Usually what I've noticed is that the lead faculty member usually puts around 30 or so questions on those assignments. So a good judge is to, look at how long it took you to complete the practice homework, because the quiz is about the same length as the practice homework. So that'll give you a good idea of how long it's going to take to complete the quiz. You can turn these assignments in. You could turn them in now if you want. So that's why I'm glad you chose Monday as a meeting time, because these assignments can come in anytime. They're open on Connect Math, and anytime you want to in Blue Quill up to the due date. So all of these assignments must be submitted by end of day Sunday if you want to get credit for them. If you don't submit them by end of day Sunday, then we do have a late work, submission, so you can submit it for some partial credit. But I can't count late work as attendance credit. You have an unlimited number of times in the practice quiz. I think if you look at it, the lead-in faculty might have set it at 2 times. If you need more than 2 times, just email me and I'll increase those number of attempts for you. So, interactive is due by end of day Sunday. Ideally, it's best to listen to the interactive lectures before class, as I said in my welcome email, because then it's like the second time you're getting this information from me. So in this format, it's a little easier to follow what's going along because you've already seen it once. But they can be done, as long as they're done by end of day Sunday, you're good. If you want to work ahead in Math Connect, just email me and I can open those assignments up early. Right now, they're set up to open as soon as like this week is when this is due, then the week 2 assignments will open. But if you want to work ahead, just, email me and I can open those assignments early for you. They just won't be open automatically. Anything else before we call it a night? These are really good questions. Any other questions from you? All right. So it looks like people are ready to call it a night. Okay, well, thank you all for coming. Appreciate you being here, and I hope to see you again next week. Hopefully, oh good, I'm glad you liked it, Erica, that's good to know. I know I'm fumbling around a little bit, but that'll only get better. So thanks for sticking it out tonight. Everyone, have a great week. Email me if you've got any questions, and I hope to talk to you again Monday night. Good night, everyone.